Moving on to question 5 here, we have a mixed bag on this question. We have a little bit on completing the square, sketching curves using part A basically to complete that. Part C is a little bit on transformations, and then the last part is finding the range of the function given. So 10 marks in total for this question. Let's take it step by step. So we start with part A. We're asked to write f of x, so f of x equals 2x squared plus 4x plus 9 in this form here. So we're being asked to complete the square on it. So this is a nice introduction to this question. Hopefully it's an easy 3 marks. So to complete the square on this, I need to play this 2 first in these first 2 terms. So what this is going to be is 2 lots of x squared plus 2x. I've got a plus 9 at the end. Plus 9. Now, I need to complete the square on this bit here. So I'm going to do 2. Now I'm going to put it in square brackets just so it's clear at the end. This is going to be x plus 1 all squared. Remember, we take the negative square of the constant, so that's going to be minus 1. And we've got the plus 9 at the end. So now we're going to multiply through, and remember you multiplied this constant here as well. So this is 2 lots of x plus 1 all squared. So this will be 2 times minus 1, so minus 2 plus the 9, giving me plus 7. And there we have it. That's 3 marks, as easy as that. Part B, we're asked to sketch the curve with equation y equals f of x showing any points of intersection with the axes and the coordinates of any turning point. So if I'm going to do part B, I'll do it down here. So I'm doing this on a mouse, so it's not going to be perfect, but hopefully you're going to get something that looks similar. So that's my y-axis. This is my x-axis. So where does this cut through the y-axis? Well, it's going to cut through when x is 0, so 0 plus 9. It's going to cut through at 9. So if I say that's 9. And where is it going to have a minimum turning point? Okay, it's a positive quadratic, so it has to be a minimum. Well, that's going to be the opposite sign here, so minus 1, 7. So minus 1, 7. So we call that there. That's my minimum point. So my quadratic will probably look something like that. So make sure yours looks a little bit neater than mine, but this is the minimum point here. So this is minus 1, 7. So that's your minimum turning point there. So again, that's the next 3 marks. So you're showing where it cuts through the y-axis, and then where it cuts, where the minimum turning point is. Part C is quite, it can be a little bit tricky. We're asked to describe fully the transformation that maps the curve with equation y equals f of x onto the curve with equation y equals g of x. So this is g of x down here, and we've got f of x up here. The first thing to note is we have this x minus 2 here. Remember your translations and transformations in general. If you've got a term on the inside of the bracket with the x, it's the opposite sign. So this is x minus 2, so this is a horizontal shift 2 units to the right. So this is 2 units, positive 2, to the right. So take this curve here and replace the x here on this 4 with the translation again. So what we'll see is that this is 2 lots of x minus 2 squared plus 4 lots of x minus 2, because this is the translation that's happening. X minus 2. We've still got our plus 9 at the end. Sorry, so what we're doing is we're substituting it into here. Sorry, ignore me there. So we're substituting it into f of x, sorry. So this is plus 9. So we've put our translation in. We won't simplify this bit. We'll just keep it as it is for now. This is 2 lots of x minus 2 all squared. What I'll do though is we'll expand this, simplify it. So this is going to be 4x minus 8. So plus 4x minus 8 plus the 9. So what I'll do is actually get rid of that. 9 minus 8, so that's plus 1. So what we should end up with is 2 lots of x minus 2 all squared plus 4x minus 3. but we've got +1. So what's the next transformation we've got to do to this, our translation? Well, I need to shift it down 4 units to get to -3. So it's a shift downwards of 4 units. Actually, I don't need to put a negative. It's downwards anyway, but we'll say -4. So if you shift it down 4, what will that give? It'll give, so therefore, this will be 2 lots of x minus 2 all squared plus 4x 1 minus 4 gives us -3. And notice this is g of x, so therefore this is equal to g of x as required. So therefore, let's just write down what the final transformation is. So it's a translation, so translation, and remember we do this as a vector, so we went 2 units to the right and we went down 4 units. So as a vector, this will be +2 because we went 2 units to the right. This is your x axis, and then we're going down 4, so this will be -4. So 2 minus 4. So that's part C1 done. And then for the last bit, II, for the range of the function. To do a question like this, you have to consider what will happen with this function. So we're considering the behaviour of it. Well, the largest value will be when f of x is at its smallest. And we said f of x is at its smallest, its minimum point, when x is -1. So if I do it down here, the largest value is when f of x at its minimum, so that's when x is -1, so largest is when x is equal to -1, x is -1, so that becomes 21 over 7, because imagine if you're subbing it back into your completed square here, that'd be 2 times 0 plus 7, so that'd be 0 plus 7, so that's going to be 21 divided by 7, because this is f of x, so 21 divided by 7 gives us 3. So the part of the range now, the largest part, so this would be h of x. So this includes this point, because this is part of the range. So it's 21 divided by 7, so it's going to include the 3 value. Now to get the smallest value, we have to consider what happens with f of x when we substitute very large values in. So this is h of x, so it's 21 divided by what f of x is. So imagine we put really large values in of f of x. What's actually going to happen is it's going to keep going bigger and bigger and bigger. So this will tend to infinity. But consider what happens then when you put this into h of x. 21 divided by, so we won't say infinity, let's consider just a really large number. So this is 21 divided by a really big number. So if you put it in your calculator, you'll get basically that it's equal to 0. Now, we don't say it's equal to 0. What we say is that it tends to 0. So when x tends to infinity, so when f of x tends to infinity, sorry. So when f of x tends to infinity, what we can say then is that h of x will tend to 0. So that's going to be our smallest value for the range, but be very careful. We don't say that this includes 0. It doesn't actually ever touch 0, it just tends towards 0. So that's the range of the function as well. So that's all 10 marks for question 5 done.